So type Seismic Unix in Google, and then you will redirect to this page. Okay, and from you can download it from Seismic GitHub, from GitHub, or from Wiki Seismic. You can download the software from here. So you can see here the data is provided, and this is the software for 44R25. This is the release version, okay, for Seismic Unix, and this is the documentation of how you can install the. Hello, am I out or something?
No, we can't hear you.
Okay,
We can hear you.
okay, so you can download this software. It's free, and you can do almost everything with this. You can like you can do coding also on Seismic Unix, but Seismic Unix uses Fortran as programming language, not C or C++ or Python. So that's a difficulty. So you can either use, this is the free software, and it is one of the best software for data processing. The only limitation is that a bulk amount of data cannot be processed with Seismic Unix at a stretch. And the second limitation is that it's not that user friendly. So user friendly means like, if you go for commercial softwares, you can see the data, and you can just click on the, like, if you want to apply mute or any kind of filtering, you can just click on the software and you can see the data. Exact on the data you can click and you can change, or you can do the changes, or you can apply the filter. But here in this case, Seismic Unix, you have to write codes, or you have to give the command, and then you run the command, and then the data or the output will be shown to you. So that is the only limitation. Otherwise, this is the one of the best software. And if you master this software, Seismic Unix, I'll guarantee that you can get admission in PhD anywhere, including USA, top universities of USA, if you have this Seismic Unix knowledge. Who is singing? Okay. I have done my processing on a commercial software using Focus, or it is a software from Paradigm. So it's a commercial software and it's very costly. So, any question? Okay. So I mean to say, if you learn Seismic Unix, and tutorial is also given, so you can see the tutorial, and there are lots of YouTube videos also on how to do the processing and everything using Seismic Unix. So you can download the data, you can download the tutorial, and you can download the documentation for the installation. And this is the software release, okay? And mind you, this can only be installed on Ubuntu or Linux based system. It cannot be installed on Windows based system. So you must have Linux based system. And if you don't have Linux based system, so what you can do is you can download VirtualBox, which is this. One second, I'll show you. You can download VirtualBox, this Oracle VirtualBox, and download this, install this, and in this you can download Ubuntu or install Ubuntu inside that VirtualBox, and then you can install. Then you can see. I have downloaded VirtualBox, and I have installed Ubuntu in this VirtualBox, and in Ubuntu I have installed Seismic Unix. So if you don't have Linux based system, so you can go for this method, and you can install Seismic Unix, and you can do the processing. But this far I'm clear, I guess, right? So this was Seismic Unix. And one more software for interpretation. See, no interpretation software is free, and they're, mind you, they're very costly, very expensive. But you can you can download this software, or you can download the Open Detect software for free, and okay, it can be downloaded. It can be installed on over Linux or Windows or Mac OS. Okay, so this software is also not free, but you can write to the person, or you can install the Open Detect software and use student license. When they will ask for license, just choose student license. So what will happen? It will get installed on your system, and then one person from one of the representative of Open Detect will contact you, and they ask whether you are a student, and if you are a student, so please provide the contact information of your teacher or supervisor or head of the department, so that they can officially mail Open Detect to provide free licensing for education purpose, and they will do that. And this is also one of the best software for interpretation, because all the videos and tutorial is available on my YouTube. And as you can see here, the data is also provided, like this FDemo, PEBNO, short force ML, and there are lots of data are present on this Open Detect software site. So if you go for this menu, so you can see here download and data. So once you go on data, so a data repository will open, and from here, what happens? Yeah. So you can see here, this is the data you can download. See, this is the, these are different data sets. These are different data sets. You can download and you can practice. Okay. And you can see here, there are lots of data are available. You can download all these and you can work on it. Okay. So I hope most of the students might have joined by now. So I'll start with the videos, which I said that I'll be starting with the videos. So can I start with the videos?
Yes, sir.
Okay. So.
Okay. Thank you so much, Deepak. I want to tell all the participants, please kindly rename yourselves, because I'm going to take note of those people that joined. All right. Kindly rename yourselves. If you can't rename yourself, please drop your name in the chat box. Your name and your school. Thank you. So you can go on, Deepak.
Okay. So let me start with this video. 1 second. Presentation is there. So this is the first video. It will show how 3D seismic data is recorded. If you have any doubt on this, can you see this video?
Yes.
See, this shows oil reservoir or oil and gas reservoir, okay, in this particular section. But since we cannot see beneath surface, so we use seismic data to image and we can to image the reservoir, and we can also quantify the amount of oil and gas present beneath the surface. And this video shows how it is why it is important for us to go for oil and gas exploration, because it constitutes almost 90% of our energy needs. So for that we go for seismic exploration. So, and it is based on the seismic exploration is based on the principle of sonar. So in sonar, you know that bats send signals, and when the signals are reflected back from a prey, so it catches its prey. Okay. And this is the ultrasound image, also just like that seismic image. So, and this is an animation for seismic data acquisition. So this is a vibrator, or we call it vibrosis, this particular PA. And this is called the recording unit. And these are the geophones. Here they have, just for the sake of our understanding, they have shown as a horizontal what do you call it? Thing, or rectangular shaped geophones, but this is not the case. We'll show you the geophone. And as you can see here, once the vibrosis hits the ground, seismic waves are generated from different layers. It's not showing for different layers, it's showing only for this reservoir, means the bottom layer. But from all the layers, you can see here there are lots of layers. From all the layers, it gets reflected and recorded by the geophone. And this is a ORV, that is called Ocean Research Vehicle. ORV is called Ocean Research Vehicle. So generally, seismic marine seismic data is acquired by this ORV, and these are the hydrophones, and this is the air gun. Okay, this black thing is air gun. So air gun blasts the air bubbles, and then the waves are generated, and again it hits the different reflectors, and then it gets recorded by the hydrophones. And this is a seismic section, looks like after recording is done. And after recording is done, this is the processing unit is showing here. So I'll end this video here. Okay. So far, any questions? If you have any questions regarding this video, you can just type it in the chat. And if not, then I'm going on to the next video. Okay, so I'll start the next video. Oh, not this one. But I will be sharing all these videos with you guys. Yeah, offshore seismic survey, like marine seismic survey. Offshore. You know, these lines, these green lines, this is called EEZ, exclusive economic zone of that particular country. So it is almost around 200 kilometers away from the shore. So every country has EEZ. They are allowed to do explorative work or any kind of research work. If they want to do any offshore research work, they can do within this EEZ. And once they go out of this EEZ, they have to take permission from the international governing body that I want to carry some particular kind of research, and the work is only for research and no other spy agency work or something. So they can do the research work or any kind of explorative work within this EEZ. And once they cross this EEZ, they need international permission for carrying out any kind of exploration work or any kind of research work over the sea. So this is called EEZ. Every country has EEZ. Even India has EEZ, and we do lots of research in EEZ because most of the oil and gas reservoirs are in this EEZ. Most of the oil reserves are found in marine scenario. And also you might have heard about gas hydrates. So gas hydrate is also one of the most, and it's called the energy of future, because the efficiency or the production of energy is much more higher when compared to oil and gas. So nowadays most of the countries are going for the exploration of gas hydrates. It's very difficult for to take out the gas hydrate from the surface of the sea because of many reasons like that. It can trigger tsunamis, many earthquakes, but countries are working on the exploration of gas hydrates. I'll be talking about gas hydrate when I discuss the case study for marine seismic data. in the coming classes. So how offshore seismic data surveying or seismic data acquisition is performed, which we will see now. So this is a oil rig. You might have seen this. This is once the seismic survey is done and the seismic, geophysicists have given the reports that okay, oil and gas are present, then they go for drilling, and they set up this oil rig for the exploration. Okay. So the question is, when they go for seismic data acquisition in marine scenario, so as we saw that there are many fishes which move around, they can affect seismic data acquisition, and it will be because see, once the air gun is blast or blast the air with high pressure, so what will happen? The waves will be generated, seismic waves, and they will go down, and they will in the oceans in ocean means in the sea, they can encounter huge fishes also, and that would be taken as noises, and it may harm the sea creatures or the fishes. So what they do is first they'll start with very less compact energy air gun. Means the energy will be very less, just to scare off the sea animals or sea creatures, so that they will move from there, and then they increase the intensity of the energy. Sorry. See, the air, this is the air gun, and this is blasting the energy, and this is the ocean, and this is the surface. Okay. So as I said that the first, just to scare off the sea animals, they produce small amount of energy so that and it is not recorded. So just to scare off the sea animals or fishes, and then once the fishes are gone, then they increase the intensity, and the waves are generated by the air gun, and it gets recorded, and it's a continuous recording. They decide a path, like if they will go in a circular fashion or a straight line, or if they have a 3D data set to acquire, so they will make a pattern according to the geo coordinates using satellite or DGPS, called differential global positioning system. We have heard of GPS. Okay, we have heard of GPS, but for seismic survey over the sea, we use DGPS. It's called DGPS. Okay, so DGPS stands for Differential Global Positioning System, and the accuracy of DGPS is around 0.1 meter plus and minus. Like GPS has a accuracy of 10 to 100 meters plus minus, but DGPS has accuracy of 0.1 meter plus minus. So it's very accurate. So we use DGPS for any kind of geophysical data acquisition over the sea. And I was fortunate enough to be a part of a scientific crew on board ORV Sagar Kanya, organized by Government of India, and I was a part of scientific crew over on that ship for 2 months, and we acquired gravity, magnetic, seismic data, gravity coring. We did gravity coring. We did sound profiling, and we also did bathymetric survey, just to see the topography or the orientation of the sea surface, so that we can make a report of all those things after the data processing using gravity and magnetic, and then we can go for the exploratory work like we can go for seismic survey, because seismic survey is very costly compared to gravity and magnetic. So before going for any kind of seismic survey over the land or sea, we do this gravity, magnetic, or any kind of potential survey. So because they are very less expensive, and once we see that okay, there is a potential of finding any kind of mineral or oil or gas, then we go for seismic survey. And once the the data is acquired, then geophysicists process the data to make a 3D structural map of the subsurface if the data is acquired for 3D in 3D fashion. And after that, what we do is, once we have processed the data and we have found any kind of oil or gas reservoir, then we go for drilling. And this is a drilling. See, here it comes straight, and then it moves like this. It's moving parallel to the ground, and this is called horizontal drilling. Again, it's also very costly, and this is done if the drill bit encounters any kind of very hard rock terrain, and it becomes very difficult to drill through that particular layer. So what they do is they start drilling parallel to the ground, and then again deep. So it's all what do you call directional based, and then the production of the oil and gas starts. So I hope this video is also clear. Now I'll show one more video, seismic data acquisition, and then we can start with the PPT. Yeah. Now, before going into to the presentation, we need to learn some what do you call terms, like what is a fold, what is a spread length, what is a bin size. So fold is nothing but the number of channels. Now suppose seismic data acquired for, like, there is one short point, and there are 8 there is a a combination of 8 geophones, so that is called 8-channel geophone. Okay, so and there are 8, 12, 16, 24. So depending on our objective, we use the spread or number of channels, and then we go for this data acquisition. So what is a fold? Does a signal that is sent into the water has any effect on the aquatic organisms? No. Yeah, see, it has effect on, obviously it will affect the sea or aquatic animals. You know why? Because see, the kind of amount of pressure is built inside that air gun is huge, so that once the energy is released, these waves will hit the subsurface, and it will go deep down up to 2 or 3 kilometers. So for going for an air gun or for an air gun to reach to generate a seismic wave of that capacity, so that it can reach up to 3 to 4 kilometers below the subsurface once it hits the seabed. So for that, they need huge amount of energy, and if an animal comes in that range, obviously it can die also. So that is why what they do is they use very small amount of energy before starting the survey, so that what happens, the animals in that particular region moves from that area. So, and after that, they increase the intensity of the pulses or air gun or air pulses or air bubbles, so that the wider range of area can be covered, so that and animals can move from that particular zone, and then they start with the actual seismic data acquisition. Is that clear?
Yes, sir.
You can unmute yourself, and you can say that. If it's clear, then I'll move to the next thing. Okay, so I'll take it as the question. It's clear. Okay, so what is fold? I'll explain with a example after this. So this is the formula for fold. So del X is the pick it in, and G is the geophone or group interval, and S is the source short point interval, and C is the number of channels. So and it is divided by half, so that will give us the fold. And I'll show you with an example so that you can understand what is a fold and why it is important. Mr. Video has started. Yeah, has started. Yeah, yeah, it has started. Yeah. See, we generally use 8-channel geophone for oil and gas surveying, because the depth of penetration is not that great, much, because most of the oil and gas can be found in between 4 to 5 kilometers of depth range from the surface for land, and for marine environment it can be found between 800 to 1 or 2 kilometers of depth range. So that is why we use who can see your messages recording. Okay, sorry. So yeah, see, this is an 8-channel. See, this is the formula for what do you call fold. And just for a normal understanding, I will show. We use 8-channel geophone, and source interval is 1 picket into interval, like spread, systematic spread, symmetric spread. So it's called split spread or symmetric spread. In this short point, it is in the middle, and equal number of geophones will be on both the. And you can see in this video how the fold is decided. See, this is the first ray. It's showing one by one how the rays are generated, and it is recorded. Okay, so you can see here. See, the offset is this much, but the fold offset is this much, and but the fold is only half of that. Okay, and it's a split spread experiment, and in this shot is moved by equal distance, so is the geophones. Okay, so you can see there are two shot points now, and there are 3 shot points now. There are 4. This is the 4th shot point, and you can see here the geophones and the source are moving with equal interval. Okay, so it's a symmetric spread, means it's moving in a symmetry. Okay. See, this is the fold coverage. Fold coverage means, see, this is the total this is the total offset of the data acquired. Now suppose if we merge all the short points and the data, so what will happen? We'll have offset of start from here and goes up to here, correct? And but the fold is from here to here, means it's like half, or not half exactly, but see, we take the mid of the spread, means split spread. Now suppose this is the end of the offset, this geophone. So the half of that geophone, and the starting position of the 4 geophones here. So we'll take that. So this range is called our fold. Okay, and data we can after stacking the whole data together, we can compute the fold. From this example, hope you can understand. Okay, again moving forward. So you can see here, see, fold was half into C into del x divided by del G and del S. So total is 8. Okay, and this is the offset. What do you call? Sorry, this is the offset. What do you call? This is the picket interval of 50 meters. Okay, and this is the short interval. Okay, for 50 meters, and geophone interval is also 50 meters. Okay, so we can compute the fold coverage, that is 4. It comes. So it is very important for conducting data processing. When we'll come to data processing, it will be important to know. As such, what to say is like uh, this gives this for 2D section, okay. But the same if we convert for 3D, so this becomes bin size. Bin size is like number of rays. Now suppose it's a 2D fashion, so it will be data is acquired along a line. But when we talk of 3D surface, so now suppose this whole screen is a 3D flat layer. So if we conduct a seismic survey, so what will happen here? We were concerned only about one point, okay. But when we talk of 3D survey, so in 3D survey also there is a concept of fold, and concept of fold means sorry, but the bin size of a bin or bin size becomes much more important in the 3D survey. So what happens for 3D survey? This point here in 2D survey there is a point, and 3D survey it becomes a bin. Bin means number of rays is tracking a particular small area. Generally, it is taken as 25 meters width and breadth. Okay, so it's a square-shaped hypothetical size or bin area which is illuminated by rays. Okay, so we sample bin by considering the number of rays falling or illuminating that particular bin. Okay, so it's very important to to get a high resolution image of the subsurface so that we can differentiate between two different structures, or if they are present very closely. Any doubts so far? Okay, so moving to the next. If the picket interval we keep as 2, means we move the source by 2, like now geophone interval is around, suppose if it is 50 meters, so earlier what we did source interval also we kept as, or short point interval we kept as 2 only, 50 meters only. But here source interval we are keeping as twice the geophone intervals. Like now if geophone interval is between the two geophones, if the distance is around 50 meters, so we keep the short point interval as 100 meters. So that is the source interval discussion 2 into picket interval. Picket is the picking interval. That's not the stacking per se for data processing. It's the like here stacking means combining all the traces to make one shot gather. You understand? Now suppose for seismic survey, for oil and gas, like for a reflection survey, the area of coverage is not that high. Only now suppose if I'm trying to find oil and gas, so my area of concentration will be, or depth of depth sampling will be around 200 kilometers, 2 kilometers, or 2 to 5 kilometers. Okay, and for that I'll have to cover only 50 kilometers of offset. Okay, in 3D fashion, like 50 kilometer on the, I have to make a spread, geometric spread or offset will be 50 kilometers to sample a depth of 2 kilometers to 5 kilometers, correct? So now suppose in one day I covered almost 10 kilometers, okay, with multiple shots. Now suppose in one day I did 10 shots, okay. So what happened? So in 10 shots, if I have acquired using 8 channel or 4 channel geophones, what I'll do is I'll prepare a FFID called first field observation identifying number, that is called FFID or shot gathers we can say. So we'll prepare a shot gather including all the data collected for that day, and then we'll stack. Stack means we'll combine all the traces acquired by all the geophones. Okay, that is called stacking here. So this data stacking is different from the stacking which we will see in the process. Hope you understand.
Yes, sir.
Yeah. So here also you can see this is the offset, and this is the stacking, means like only see this particular area is not covered or sampled by the trace, correct? This particular area is not covered by the trace, but the geophone but if you go on the directly overhead this, so the one geophone is here. So the area beneath geophone, see, you see that this area has not been illuminated with the seismic wave, so we'll exclude that. Okay, so only the point which has been illuminated with the seismic survey. Illuminated means like the seismic wave has tracked that area and get reflected back. So that is called illumination, and this whole region is called zone of illumination. Okay. Sure. Okay. So this is called illumination of the surface. So you can see here, this area is not sampled with the geophone. So the only area which has been sampled through the geophone, that those particular what you call data has is tagged to form a fold. But on the offset, on the surface, we have seen that the area of coverage is, now suppose this is 100 meters. So the sampling will be around, now suppose 10 meters leave here and 10 meters leave here. So only 80 meters of the area of the subsurface has been illuminated, and the data has been acquired, and we can image only this far. We cannot image this data, this area, because this has not been illuminated with the help of seismic wave. So that is why fold is important, to know how much area has been illuminated with the help of the seismic data. So fold is important for that. Again, you see, fold coverage is like, see, first for number of rays hitting this area. This is only one. Now once and it is acquired by the first 4 geophones. Okay, correct. So after that, when we move the shot point, so what happens? Number of rays tracking that particular area has increased. Now see here, you can see here, there are 2 waves, like from the first shot point there is one wave, and then from the second shot there is one wave. So you see here that this area has been illuminated twice. Okay, that is why it's showing 2 here. Okay, and if as we go like as we increase the spread length, so the stacking or the number of number of times the area illuminated by the wave will increase. That is why you see this is 1, 2, 2, 2, and then again 1. That it means this area has been sampled only once, and this area has been sampled twice, because seismic wave hit the that particular area 2 times from different shots fired and acquired by the geophones. Correct? And for asymmetric, this is called end-on data acquisition. Okay, so there is only one shot point here. Sorry, there is shot gather here, and there is only one. There is geophones only on the one side. So this is called spread. Okay, or end-on spread. Okay. See here, the area of illumination is this, and the area which has not been sampled is very less. So most of the time, this kind of survey is organized. Again, here it is totally dependent on the objective which we want, for what kind of what is my objective. Okay, and based on that, we choose what kind of survey we want to do. See, and then we move the geophone. We move the short interval by equal. See, here the geophone interval is around 50, so we move the short point interval for short point by 50 meters, and then we placed one geophone here. Okay, it's called asymmetric because symmetry is not a concern here, because see, in symmetric we kept equal number of geophones on either side, but here we are keeping different number of geophones so that maximum area can be covered by the seismic. So now it became symmetric. Once we have reached equal a particular distance, and my number of geophones, because see, I'm using 8-channel geophone, so maximum number of geophones which we can use either side is 4 and 4. If you go for 12 geophones, then we'll use 6 and 6. If you go for 24 geophone channel, we'll use 12 and 12. Then again, see here, once we have once we have reached symmetric spread, see again the area of illumination has become less and the area unsampled. If you forget about the previous short points, now forget about previous short points. So only consider this short point. So area of illumination is only this much, and area which has not been sampled is bigger. Okay, so that is why in most of the cases we go for or end-on shooting or asymmetric data acquisition. And again, see here, because if my offset is fixed, so again after certain, my number of geophone will decrease on the right side. Okay, so that we can sample most of the subsurface. Okay. See, here also in this case, for end-on short point or asymmetric short point, short intervals, what we saw, the area of which has not been sampled is very less here and here, and area of illumination is higher when we compare it with the symmetric. Okay, and as you can see here, the stack fold coverage or stack chart which you see here. So we see that this particular point has been sampled twice. Okay, and here also it has been sampled twice, and then 4 times, and then again 2 times. So that means why it is important to know why one particular point has been sampled multiple times. See, what happens if you have huge number of data set pertaining to one particular region, what we can achieve is we can achieve higher resolution, because we have a data set for that particular area multiple times. Like now suppose if I have now suppose there are 2 students in a class, and one scored 100 marks and one scored 60 or 50 marks, and we take an average, what will happen? The average of the class will be 75%, correct? 75%. So that gives that means that both of the students have acquired 75 marks, which can be misleading. But if there are 100 students in that particular class, and so the number of samples have increased from 2 to 100, because number of students has increased, and after that, if we take the result of that particular class with 100 students, and we take an average score of all of that particular class with 100 students, okay, so what will happen? It will give me more precise average of the class performance compared to the class with 2 students only. Got it? My point? Got my point? So that is why if I have huge data set or multiple data sets for one pertaining to one point, what will happen? It will give me more certainty to get a better picture of that particular point or zone during seismic data processing. Okay, so that is why sampling of one point with multiple seismic wave is very much important to get the exact picture of that particular subsurface or zone. Okay, I hope I am clear so far.
Yes, sir.
The next. See, it's showing geometric spread of yeah, it's showing the symmetric split shooting and asymmetric. You can see here it has the coverage is huge. Means the coverage subsurface coverage is huge in this particular end-on shooting and compared to this. Because obviously the offset is higher in this, but as you can compare these two, the area of illumination is this much, and the area which has not been sampled is huge on both the sides when we talk of symmetric spread, and when we talk of asymmetric spread or end-on shooting, the area which has not been sampled is less. That means it covers maximum subsurface area. So most of the time, this kind of seismic survey is preferred uh, when compared to symmetric spread. But both of them has uses what do you call need. We go for type of seismic survey. This is best, this is for for both. This is applied for both land data and marine data. Okay, it's showing my internet connection is unstable. So in marine cases, mainly generally we do this end-on shooting because it's very tough to get symmetric spread, but it can be achieved when we talk of like bottom simulating reflector. When we go for a bottom simulating reflector, in this what we do is we plant the hydrophones on the bottom of the surface, then we can go for this. But generally we go for end-on shooting and marine survey, but on land survey we can go for this. And you can see here this gives the fold what do you call plot this symmetric and asymmetric. As you can see here, the full fold of this asymmetric is huge compared to this, and taper zone for this is also again it's huge when compared to this, and the no fold or the unsampled is huge when compared to the end on. And these are called CDPs, common depth point or common midpoint. That's same thing. Common depth point means like a seismic wave striking that particular layer. See, this is one layer. Okay, so this is the common depth. Means now suppose this is 20 meters, so all the seismic wave is hitting this. This is called common depth point. Okay, but there is one more thing is called common midpoint. In that, what happens is both the I'll discuss that with much more in detail when we'll go to the presentation. But to give an example, stop, don't back. Okay, so common midpoint is by the name you can see that all the the shot and the geophones are moved in such a way that one particular point. Now suppose this is my point, okay, of illumination, and this is my shot and this is my geophone. So what will happen, will collect the data in such a way that all the geophone is moving and the source is moving, and on this particular point is sampled and no other point. Okay, so this is called common midpoint. Only one point, midpoint of geophone and the shot is sampled. It's called common midpoint. But when CDP is same as CMP. Okay, but for a broader picture we call it as CDP because it's tracking only one surface, a common depth. So it becomes CDP. And CDP and CMP are almost same because now suppose if you take this geophone, and this becomes the midpoint for this particular shot and this particular geophone. Okay, see this shot, this shot goes and this geophone. Okay, so meaning to say that geophone is moving and source is also moving, and it's sampling only the mid portion of the mid of the geophone and the source or shot point. See, it's showing how the short point is moving and the geophone is moving, and this is the receiver interval. Okay. Source interval. CDP number is equals to picket numbers into 2. Picket numbers is nothing but the these geophones, number of geophones, total number of geophones. Not important. See, this is called short point 1. SP1 means short point 1, and this RP1 means receiver point 1. Okay. And this is the CDP1. This area, this particular zone where the data, first seismic data has been has striked or eliminated. So CDP1 can be given with this formula, but it's not important, so you don't worry about this. This is just for the sake of understanding, but it's nowhere can be used in while processing, seismic data processing. So this was the last video. If you have any doubt, you can ask questions. Okay. Do you have any doubts? Or shall we end this discussion here today, and then we'll start with data acquisition and signal processing tomorrow, like combined data acquisition, because understanding data acquisition and processing together will be good. So if we'll say that, I'll end the talk here, and we can do the rest of the data acquisition and signal processing, because see, before going to the seismic data processing, we need to know signal a little bit about signal processing, so which we will discuss tomorrow. And just for the sake of this data acquisition, I'll show you types of geophones. This is called a 3C geophone. That means 3-component geophone. So it acquires data with vertical, horizontal, and this is the vertical, and these are the 2 horizontal spikes. So it goes down, so it will record the data in vertical sense and 2 horizontal sense, like radial and transverse, or northing or easting. Now, when a seismological data or earthquake data is acquired, so you might have seen that there is written N, E, and Z. So Z means vertically down, N is northing, and east is E is eastings. So that is the concept of earthquake data. It is always recorded in orthogonal direction, like all the 3 spikes or 3 sensors will be orthogonal. But the same kind of concept which we have incorporated for active seismic data acquisition. So we use 3C data, that is called 3-component data. Okay, so there it records 3 components of the seismic wave. The first component is vertical component, that is Z, and the 2 horizontal components are easting and northing, which is rotated to make transverse and radial according to our profile, which we will discuss when we'll talk of case study. Okay, and this is called the single component geophone. Mostly this is used for seismic survey. It requires vertical component only, and this is the geophone. Hydrophone. This is used in case of marine seismic data acquisition. Okay, which we have seen in the first video. How the marine Scrappy, no, sit down. Okay. So what you say? Shall we end the discussion here and continue from here tomorrow? And we'll be discussing more about the data and signal processing, and then we'll move on to the actual case studies in the next week. And by the time we will be down, you might have downloaded the Seismic Unix, so that we can talk about Seismic Unix a little bit also. What do you guys say? Please.
Yeah, I think that would be very okay for us. So
you are not audible. Kindly unmute yourself.
Okay, I said it will be fine. We can do the next part tomorrow.
Yeah.
Yeah, so I guess that will be the end of your presentation today.
Yeah, if you guys are okay, then I can go further because almost 86 slides there in this.
Wow, 86 slides. Okay, I think it would be better for us to start that one tomorrow.
So see, I have given you the basic understanding of data acquisition, and so we'll be talking about geophones, hydrophones, working of geophones, and objectives before planning a seismic survey in the coming this slide. In these presentation, I'll be talking about objectives and the kind of planning which is done before going for the seismic survey. So you have a understanding of how a seismic survey is done, and now we will talk about the mechanism involved for a seismic trace to be recorded on a seismogram, and working of geophone, working of hydrophone. So you guys can do one thing for today's lesson. You can out the working of a geophone and working of a hydrophone, how it works. I'll give you a hint. Do you guys know about or have you studied about electromagnetic flux? During
Yes.
your you might have read about the electromagnetic flux, right?
Yes.
So when a magnetic flux moves through, or a magnet or a coil, electric coil moves through,
Generates current.
so it generates currents. So that current is recorded to give the movement of the ground. So that means indirectly it gives the seismic wave, or it records the seismic wave. So that is the working of a geophone. So electromagnetic flux is the mechanism for geophone, and for hydrophones it's piezoelectric effect. What is the piezoelectric effect is? Now when a air gun shoots air bubbles, so what will happen? Pressure is released, it goes down and it comes and it hits the hydrophone. So pressure is created, and because of that pressure, what happens? Electric currents are generated, and then it gets recorded as a seismic wave. So I'll give you this work to find more about the working of geophone and hydrophones, and also find about the working of this 3C three component geophone. Is that okay, guys?
Yes, sir.
Okay. So you guys work on it, and I'll ask tomorrow about these things, all these geophones which I told or discussed here. Okay. So the next class, which when we'll meet tomorrow, we'll be discussing more about data acquisition. And in meantime, please download the seismic Unix, and also the OpenTect software. And you can ask your teachers to send an official mail to the OpenTech, and they will provide you free softwares, and you can do everything in that. They will provide you data, so that will be a very great learning experience for you guys. So now suppose, what is the main objective after your master's degree? To get a job in an oil company, correct? Right?
Yes, for most of us.
Most of us. Okay. For that, what you need, you should be good at seismic data processing, or you should be a good interpreter, correct? Okay.
Correct.
What happens? Most of the institutions around the world, even including USA, they don't provide students with the what do you call commercial softwares. Okay, because commercial softwares are very costly. Only the research institutions in which I was working or I'm working, they have commercial softwares. But any educational system or colleges, they cannot spend a huge amount of money on just on softwares. Okay. Okay. So you have an opportunity to get OpenTech for free, and you can learn, and there are videos. All the videos are there in the OpenTech site, or you can find it on YouTube as well. You can learn from there. And for Seismic Unix, tutorial is given. Videos are also there on YouTube, and you can learn from that. See, the beauty of Seismic Unix is that you can do processing, you can do coding, you can do even like you can write your own code for seismic data simulation, like using finite difference method, or very uh, advanced algorithm. You write an advanced algorithm in Seismic Unix to make your own code or make your own software, or you can give a plugin in Seismic Unix, and your name will be there in that Seismic Unix repository that you have contributed this. Okay, so it's a Seismic Unix is the best software for learning seismic data processing and even modeling. So my request to you all is to download Seismic Unix, start working. Data is also available on that. Okay, and I can guide. See, I'm not an expert in Seismic Unix, but I am expert in processing. But I can guide you guys, yeah, how to. Uh, 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 Sorry, I was not visible. Okay, yeah. So how to if your processing steps are correct or output is correct or not. Okay, where you have done mistake, how to proceed with different steps of seismic data processing. So I can help with that. Okay, and all the codes or commands, you can find it on the tutorial itself. Okay, and you can find the flow chart also. Okay, what steps you have to follow in the tutorial, Seismic Unix tutorial. So once again, I'll show you. Let me. Yeah. Again, once again, I'll send the link to you guys and you can download. So this is the link. I'll paste it here for Seismic Unix. You can copy this link, and for OpenText, this you can copy paste it right now in your browser so that you can download it means later. Okay, and for data also, this is the data set. Data repository is already there in DGB website, so you can download it from there. Okay, and other packages for petrol and everything, you can download everything, and they provide for student licensing. They provide free for free. So it's a good opportunity for you guys to learn about with these softwares. So with this, I'll end today's talk. And if you guys have any questions, please shoot. And otherwise, we'll end the session. Please.
Thank you very much, Deepak. Is there anyone that wants to ask a question? If you want to ask any question, please unmute yourself and ask. All right. In the absence of no question, probably you have question later. You can.
Yeah, if you don't have a question here right now, so you can write it to me. My email ID is with you guys, I guess. And if not, so
Yes.
here is my email ID. You can write it. You can write to me. You can ask me any question, or not only questions. If you need any kind of help, or if you want to clear a concept, or anything regarding seismic data processing, modeling, inversion, seismic anisotropy, I'll be very happy to help you guys. Or even like, see, if you want any kind of career advice also, I can help. But my main aim is to make you guys aware that you, or make you guys like that you can for a PhD in USA or UK. Okay, where you can get better facilities and better infrastructure for your PhDs. Okay, and because why I'm saying this UK and USA, because see, once you go to USA or UK and you do your master's program from there, so your career will shoot like you will not have to look back, and you'll be earning huge, and you'll be learning lots of things. So that is my main objective, so that you can guys develop your knowledge in such a way that you can become huge in geophysics, and people will be calling you guys for any kind of demonstration or any kind of lecture. So that's my motto. So If you have any kind of questions, career related or anything, so please don't hesitate to write to me or message me on LinkedIn. And if you need my WhatsApp number, so Rodia has my WhatsApp number. She can share with you guys.
Thank you so much, Deepak. I think everyone heard what Deepak said. He said like the big reason why he's doing this is for us to be relevant, like for you to stay relevant, so that you will be useful in geophysics. Like you'll be strong, you'll be called for. You you have something to offer, right? So please don't take this training with levity. Be serious with it. Go to the Unix website, the Open Deck website. Okay, I'm going to try to contact the school so that they can
Yeah.
help us to get a free license for the Open Deck. But for now, you can.
And one
All
more
right.
thing, one more thing I'll say is that seismic method is not a thing that can be covered in 4 or 5 days. So what I'm trying to do is I'm trying to only talk about the important stuff which is necessary for seismic data processing and modeling. So rest of the things you can I have referred some books to you guys. Rest of that you can follow those books, and it is easily available online. You can just search that geophysics Russian library karke. Means there is a open library like geophysics library Russia. You just type that, and that link will open, and you can download any geophysics book from there. So you can go through all those books, because seismic method is huge, and it cannot be completed within 15 or 14 days, or even not even 14 15 days, 6 or 7 classes. Okay, so I'm trying to keep the classes as much contact, and only talking about the important stuff. So and I know that I'm missing lots of things in this course, because I cannot cover everything in this short span of time. So it's your duty to go to the books and make increase your knowledge. And if you need Ilmaz is the best book for seismic data processing and understanding seismic. Okay, so if you want Ilmaz book, I have it with me. I'll show you. This is only one volume. I'll show you of Ilmaz. 1 second. Oh, yeah. 1 second. Yeah. Where did it go? Yeah, you can see this. This is just one volume of Ilmaz. Okay, so one more volume is there with me in my lab. So I have the soft copy of this book also. I'll forward that soft copy of the book to you guys. And if possible, you can follow this Ilmaz book, seismic data analysis, seismic data analysis by Jose Ilmaz. So you can follow this book. I'll send it to Rodia, and she can forward it to you all guys. Okay. So this is the best book. Follow this book, and you don't have to follow anything else or worry about anything else. Okay. Oh, okay. So with this, we should end, right, Rodia?
Oh yes, we can end the
Yes.
we can end the session.
Have a relaxing Sunday, and good night.
Deepak, please, I think someone has a question. Erin,
Okay. Yeah, please.
Erin, please, can you unmute yourself and speak?
Or you can type the message or question.
It's okay. Can you hear me?
Yes, but your background, we can hear you, but your background is noisy.
Yeah, background is noisy. So please type your question, please, because my internet is not stable, so I'm not able to yeah. Please type your message.
Okay, while we wait for Erim to type his questions, I just want to make an announcement. If you are not a member of the SEG and you wish to know the benefits of the SEG Women's Network is going to be having a session with the SEG President Anna Sharinesi by Friday, 13th of May, 9 a.m. US Central Time. That's 3 p.m. West African time for us here. So I just want to encourage you all to join. You can check SEG Women's Network on LinkedIn or check SEG Footers page on LinkedIn. You'll see the link. So it's going to be a very informative session. So just come, bring your questions, anything you want the SEG to do for you or anything you think SEG needs to do better, come and tell the SEG president. All right. I don't know. Erim, are you still typing?
Yeah, well, let's continue. I'm finding difficult to
All right. So I think Erin will get back to you, Deepak. I think he's having problems, having some difficulties.
Yes, I'm having some difficulties here.
All right. So this is the end of the session today. We are expecting you tomorrow at the same time, 3 p.m. West African time. Thank you so much, Deepak. We are very grateful.
Thanks a lot. Thanks a lot. It was always a nice pleasure talking to you. Which is more preferable between OpenText and Seismic? See, Seismic Unix is for seismic data processing, and OpenText is for interpretation purpose. So these two softwares are for totally two different work, So Seismic Unix is generally used for data processing, and OpenText is for seismic data interpretation. So you have to download both. Because see, you have to learn both seismic data processing and seismic data interpretation. So you can download both and install both. Please mute yourself. Yeah. So, no further questions? Further questions?
It's okay. I think Futmina, David, do you have something to share? All right, the other presidents are not around because they are.
Sorry, I can't hear you.
I said, do you have anything to share?
No. I appreciate the lecture. Thank you very much, sir.
All right, thank you. On behalf of SegWeb's African section, I would like to say thank you to every one of you for joining our session today. We hope to see you tomorrow also. Thank you so much, Deepak. Everyone, have a nice weekend.
Yeah, thanks a lot. Okay, bye. Have a great day, guys, and a happy Sunday. Enjoy your day. And I took almost 1 hour and 20 minutes of your time. So we'll see you. We'll meet again tomorrow. I'll leaving and good night.
Bye. Bye.